Hello, lovely people. Welcome to Mrs. Baker's Chemistry Corner. This is the Monster paper for Module 5, and this is question 9. So, barium carbonate reacts with dilute hydrochloric acid, and here is the balanced equation. It tells us that we have 9.85 grams of barium carbonate, and that we had 250 centimeters cubed of a 1 mole per decimeter cubed hydrochloric acid. It tells us already we have an excess of hydrochloric acid, so we know for our molar ratios that we're using the barium carbonate. Got aqueous solutions, and we've got the mass moles MR. So we're in this red mass triangle up here, and we're also in the aqueous, green aqueous triangle down here, the mole conc vol. So we need mass, mole, MR. We also need conc and vol. Okay, so we've got our table drawn. We put in what we already know. We've got barium carbonate and we've got hydrochloric acid. And we can see already that we've got a 1:2 ratio. So let's put in what the question tells us, 9.85 grams. If we've got 9.85 grams, we can then work out the relative molecular mass of barium carbonate. So barium is 137. Carbonate is 12 plus 16 times 3. Let's put that into our calculator. 137 plus 12 plus 16 times 3, and that gives us 197. So now we've got our mass and we've got our MR. We can now divide the mass by the MR to get the moles. So 9.85 divided by 197 gives us 0.05. So that's how many moles of barium carbonate we've got. We know that hydrochloric acid is in excess. So how much hydrochloric acid can we actually use? Well, we use twice the amount of the barium carbonate because it's a 1:2 ratio. So while we've got it on our calculator, let's just times it by 2, and we see that actually we can use 0.1 moles of hydrochloric acid. But because it's told us that it's in excess, we are probably going to have to work out later on how many moles of hydrochloric acid were in excess. So let's work that out while we're at it. Let's go back up and have a look. We've got 250 centimeters cubed of a 1 mole decimeters cubed solution. So let's look at how much we had. We've got 250 over 1,000 because we have to put it into decimeters cubed. So that's 250 divided by 1,000. That gives us 0.25 decimeters cubed. Our concentration was 1 mole per decimeter cubed. So we do 0.25 times by 1 gives us 0.25. So we had 0.25, but we can use 0.1. Now we can go back to our questions because I think we've got all of the answers. Calculate how many moles of barium carbonate were used in the experiment, 0.05. Now, how many moles of carbon dioxide were used? Oh, how many moles of carbon dioxide were made when the barium carbonate had reacted? So if we've got 0.05 moles of barium carbonate, then we've got a 1:1 ratio. So we must have 0.05 moles of carbon dioxide made because they're both a 1:1 ratio. Calculate the volume of carbon dioxide formed at room temperature and pressure. So if we've got, for this we need to use our vol mole 24 triangle. We want to find the volume. We do the moles, 0.05 times by 24. So let's do that. 0.05 times by 24 gives us 1.2. So 1.2 decimeters cubed worth of carbon dioxide formed. Now we need to calculate how many moles of hydrochloric acid there were in excess. So we had 0.25. We minus off the 0.1. That gives us 0.15 moles left.